Hello and welcome to a brief introduction to the book Information Theory, Coding and Cryptography, the third edition. It is written by Ranjan Bose. Let's start with the primary objective of this book. The main objective of this book is to arouse the curiosity of the students. Who are the target audience for this book? Well, students of electrical engineering, electronics engineering and computer science are the primary targets of this book. Final year undergraduate students and first year postgraduate students can also use this book efficiently. This book can also be used as a quick reference for practicing engineers. Also, participants of short-term courses, quality improvement programs and continuing education programs can also use parts of this book. Let us now look at the organization of this book, the third edition of Information Theory, Coding and Cryptography. The third edition is divided into 4 logical parts. The first part deals with information theory and source coding. Part 2 deals with error control coding, also known as channel coding. Part 3 concerns with codes on graph. These are essentially codes with memory. And finally, the fourth part deals with coding for secure communications. Now, let us look at Part 1 in slightly greater details. Part 1 concerns with information theory and source coding. It has 2 exciting chapters. Chapter 1 deals with information and its efficient representation, while Chapter 2 deals with channel capacity and coding. If we look at Part 2 of the book, which deals with error control coding, we find that there are 4 practical chapters. Chapter 3 deals with linear block codes for error correction. Chapter 4 deals with cyclic codes, which is a part of linear block codes. Chapter 5 deals with Bose-Chaudhuri-Hockingham or BCH codes. We will also look at Reed-Solomon codes within this Chapter 5. Chapter 6 deals with space-time codes. Let us look at Part 3 of this book, which deals with codes on graphs. This part has 2 fascinating chapters. Chapter 7 deals with convolutional codes, while Chapter 8 deals with combined coding and modulation. Specifically, we will talk about trellis coded modulation or TCM. Finally, we go to Part 4 of the book, which deals with coding for secure communications. This has 2 very interesting chapters. Chapter 9 is all about cryptography. We will study classical cryptographic techniques in Chapter 9. Chapter 10 is different. It deals with physical layer security. It is based on concepts from information theory. So, we ask ourselves the next logical question: what is so exciting about this book? Learning objectives. One of the interesting features of the third edition is that every chapter starts with a clear-cut list of learning objectives, which are closely linked to the topics covered within the chapter. Each section within the chapter is tied to a specific learning objectives. Why is this important? This will help the student better anticipate what they will be learning within the chapter. Let us now spend a couple of minutes on the pedagogy of this book. The pedagogy is arranged as per levels of difficulty. We have used Bloom's taxonomy. Every problem is marked with an S, M or a D. S represents easy to solve problems. Basically, they test the knowledge and comprehension of the student. M indicates medium difficulty problems. They deal with application and analysis, while D is high difficulty problems, and that concerns with synthesis and evaluation. So, during the course of every chapter, the student will attempt S, M and D so as to clarify the concepts taught within the chapter. So, it is important to highlight this point. All questions and problems are linked with learning objectives, and all questions are marked with levels of difficulty in the third edition of Information Theory, Coding and Cryptography. Another unique feature of this book is that all useful information is highlighted within the text. So, if you look at the text of the third edition, you will have various tags on different pages. The interesting concepts are marked with "Did you know" tag. You also have more important concepts labeled with "Don't forget" and "Take a look." Wherever we have invoked intuition, we have put the intuition icon. At places where results have interpretations, we put the interpretation icon. And whenever a concept has immediate industrial relevance, we have put an industrial relevance icon. Thus, the students are kept engrossed by highlighting all the useful information within every chapter. Another interesting feature is the learning outcomes. Every chapter ends with a telegraphic summary where all the important concepts and formulae are compiled. This will enable students to quickly and efficiently revise the key concepts before the exams or before an interview. Here is a sample of learning outcomes taken from chapter 1 of the book. In-text examples. Examples are very effective teaching tools. Whenever a new concept is introduced in a chapter, it is almost invariably followed up with an example. The revised edition contains over 210 solved examples. Here is an example of an example taken from chapter 1. In-text exercises. As we have mentioned before, linked to each learning objective, there is a set of in-text exercises marked with levels of difficulty as per the Bloom's taxonomy. So, here is a sample of a learning review. As you can see, questions are linked to a certain learning objectives. In this case, it is LO1, and every question has a level of difficulty S, S, M marked here on the right. Thus, if you look at the entire learning objectives, the student can solve a set of questions and finally is able to master the topics once the student solves all the problems linked to the certain learning objective. Let us now spend a couple of minutes on the types of questions contained in the third edition. This book contains a variety of questions linked to different aspects of the chapters. We have multiple choice questions denoted by MCQs, which test the higher order thinking skills of the student. We have short answer type questions, which test what the student knows and what the student does not know. At the end of each chapter, we have chapter end problems. They help crystallize the concepts learned within the chapter. Many concepts are better understood by writing computer programs to solve them. So, every chapter contains a set of computer problems at the end. We have already talked about in-text exercises, which helps students to crystallize the concepts linked to a certain learning objectives. Finally, a unique feature of this book is the set of project ideas given at the end of each chapter. The enthusiastic students are encouraged to work individually, in teams, and under faculty supervision to attack these open-ended project ideas. Let us now have a brief introduction to the chapters contained in the third edition of Information Theory, Coding, and Cryptography. Chapter 1 deals with information and its efficient representation. The learning objectives of this chapter are LO1, understanding the concept of information. We will then look at the source coding theorem. We will then discuss some important source coding techniques like the Huffman coding, Lempel-Ziv coding, run-length coding. We will look at the optimum quantizer and finally apply this knowledge for image compression and video compression. Chapter 2 deals with channel capacity and coding. The learning objectives are to categorize different types of channels and channel models, to determine channel capacity mathematically and understand how to calculate the capacity of a given channel. We would motivate the need for channel coding in the context of the noisy channel coding theorem. We will look at the information capacity theorem and finally discuss random selection of codes in Chapter 2. Chapter 3 introduces the reader to the fascinating world of linear block codes for error correction. What are the learning objectives of Chapter 3? Well, we will first understand the basics of error control coding and the process of encoding linear block codes. Subsequently, we will look at the decoding strategy. We will study some known good linear block codes and finally take a quick peep at the wonderful world of space-time block codes. We will discuss space-time block codes in greater detail in Chapter 6. Chapter 4 deals with cyclic codes, a very useful and practical subclass of linear block codes. The learning objectives are: first, to revise the concepts of polynomials and learn how to generate cyclic codes using generator polynomial representation. Then we will study some popular cyclic codes used in the industry. Finally, we will explain how to implement cyclic codes using circuits. Chapter 5 deals with Bose, Chaudhry, Hocquenghem or BCH codes, which is a useful subclass of cyclic codes. The learning objectives of Chapter 5 are to develop mathematical tools including the ideas of primitive element and minimal polynomials to study BCH codes, define BCH codes, learn how to encode them and to decode them efficiently, and finally learn about the powerful Reed-Solomon codes and understand how these Reed-Solomon encoders and decoders work. Chapter 6 is a very interesting chapter which deals with space-time codes. What are the learning objectives of Chapter 6? Well, number 1 is to learn the basic idea behind space-time block codes and understand what do we mean by diversity gain, coding gain, and read about the rank determinant criteria. Then we will go on and define real orthogonal design, generalized real orthogonal design, complex orthogonal design, generalized complex orthogonal design, and finally quasi-orthogonal space-time block codes. Finally, we will look at the space-time block code design targets and carry out basic performance analysis. Chapter 7 changes gears and looks at codes with memory. We will discuss various aspects of convolutional codes, another a very practical set of error control codes. We will learn the basic concept behind convolutional codes and learn how to use polynomials and generator polynomials to represent convolutional codes. After learning how to encode them, we will discuss how to perform Viterbi decoding in order to decode convolutional codes. At the end of the chapter, we will take a look at turbo encoding and decoding and also discuss interleaver design for turbo codes. Chapter 8 deals with combined coding and modulation. The learning objectives of Chapter 8 are to explain the basic concept of trellis-coded modulation called TCM and carry out encoding using a TCM scheme. Then we will study how to perform TCM decoding again using Viterbi decoding. We will also learn how to design good TCM schemes for white Gaussian noise channels and fading channels. Finally, we will look at space-time trellis codes, also known as STTC, and learn the STTC design criteria for fading channels. Chapter 9 is all about cryptography. In this chapter, we will first study the basic operations used by common encryption techniques. We will talk about secret key cryptography and specifically look at data encryption standard, IDEA and RC ciphers. We will then talk about public key cryptography. We will discuss RSA algorithm, PGP or pretty good privacy, and look at one-way hashing. We will also study Diffie-Hellman protocol for key exchange, elliptic curve cryptography, quantum cryptography, biometric encryption, and chaos-based cryptography. Finally, we come to Chapter 10, the last chapter in the book, that deals with physical layer security. This is essentially security based on concepts of information theory. We will start by explaining the basic idea behind Shannon security, wiretap model, the degraded wiretap model, and learn how to calculate secrecy capacity. Then we will go on and discuss the Gaussian wiretap channel and learn how to determine the secrecy capacity of wireless channels. We will also define outage capacity and the outage probability. Finally, we look at two very interesting techniques, cooperative jamming and artificial noise forwarding, to improve physical layer security. This summarizes the different chapters of this book. Let me conclude with a brief about the author. Ranjan Bose is a professor in the Department of Electrical Engineering at the Indian Institute of Technology, Delhi. He obtained his B.Tech degree in electrical engineering from IIT Kanpur and MS and PhD from the University of Pennsylvania, USA. He then worked as a senior design engineer with Alliance Semiconductors. Since November 1997, he is with the Department of Electrical Engineering at IIT Delhi, where currently he is the Microsoft Chair Professor. He has served as the National Coordinator for the Mission Project on Virtual Labs. He has also developed a video course on wireless communication under the National Program on Technology Enhanced Learning, NPTEL. He is the founding head of the Center of Excellence in Cyber Systems and Information Assurance at IIT Delhi. He has served as guest scientist at various universities, including the Technical University of Darmstadt in Germany, University of Colorado Boulder, USA, UNIC in Norway, and University of Maryland, Baltimore County, USA. He has been presented with the URSI Young Scientist Award, INA Young Engineers Award, AICT Career Award for Young Teachers, the Boy Scouts Fellowship, and the Dr. Vikram Sarabhai Research Award. He is the Fellow of IIT and a Humboldt Fellow. With this, we come to the end of the introduction to Information Theory, Coding and Cryptography, the third edition, written by Ranjan Bose.